All right, cool. Welcome back. All right, bunch of things to talk about today. So, first thing, I posted an announcement on Canvas. As most of you know, I pretty much always record and post the lectures from my classes on YouTube, and then I put a link to the channel on Canvas. And I try deliberately not to, expose student names and things like that. So when I hand out homework in the classroom, right, I don't record that part when I'm reading out names. So on Zoom, right, I don't have my chat window up, I don't have my list of participants up, and so on. I'm just showing you my desktop, which is mostly just my document camera or a terminal window or a browser. But the administration sent around a note yesterday basically suggesting that recording students asking questions can be considered a privacy violation, and they're concerned about that. So I'm doing the following alternatives. So if you have privacy concerns and you don't want to ask a question and have your asking of that question recorded on this video, because these videos are posted, publicly on YouTube. If you don't want yourself recorded, there's a couple of options. The first option is, you can just ask your question, but tell me, don't record this, and I will note where in the recording we are, and I will chop that out before I post. Okay, I already do that when I accidentally mess up and bring up the chat window and stuff. The other option is, if you look at your list of participants, you'll see me there twice. One is just Nick Macias as the host. The other is Nick Macias, and it says questions next to it. So you can send me a private message to that host, right? And that's on my cell phone in front of me. I'll see what that is, and then I can read the question to the class, and I can address it. And if you have follow-up questions, you can send that in the chat and so on. So your choice, either way. And if you're not worried about, random people hearing your voice, you can just go ahead and ask questions as usual. But if there is, any concern with privacy, you have those two options. If neither of those seems appropriate, or you have some additional concerns, right, please let me know. Shoot me an email. It's probably the best way to get a hold of me, and we can figure out what to do. But hopefully that works for everybody. If not, just let me know, and we'll figure something else out. All right, so PA1, I have that from everybody at this point, with a few exceptions. So I will get grading on those as soon as possible, but normally you turn your projects in on Friday, and Monday you have your grades. They're being turned in the middle of the week this time, right? Tuesday, so I'm probably not going to get them graded today. I may not get them graded tomorrow. It might be a few days. Okay, worst case, it might not be until after the weekend, but hopefully it'll be sooner than that. But once I have them graded, I will post them, the grades on Canvas with feedback in the comments section. Okay. All right. So, any lingering questions on PA1 before we go on? All right. Well, let's hop into PA2. So PA2 is a return of the word index program that we've touched on in other courses. This will be a fairly different experience in 223 from how it was in, say, writing this in C. It's going to be a different feeling, but it's going to be considerably easier than doing this the way we've done it in the past. So the basic setup is your well, let me give you the disclaimers up front, right? This is it's more complex than programming assignment 1, but not necessarily harder, okay? It's not going to be, a significantly more amount of code that you have to write for this. In fact, the code will be fairly slim if you're doing this the right way. The main challenge here, which we talked about a little yesterday, is trying to think in an object-oriented way, trying to think of objects as encapsulating data and code, okay, methods for manipulating the data, so that we can create an object like a hash map where the data values in the hash map itself are linked lists, which are, you know, a collection of objects which are integers, right? And we're going to take that and we're going to put it into a new object we're creating of a class that we call indexer. So we're going to be layering these classes inside other classes and layering on top of that. It's going to be a lot about trying to figure out how to organize this stuff. Okay, getting a nice, clear, consistent image in your head, and then implementing it. And if you have a good image in your head of what this all looks like, the implementation is not bad. Okay, and I dare say it's actually kind of fun to code like this. Hold on, I'm switching chairs. But it's going to be challenging at first, okay? So this is one of these things where, you know, if you sit down Thursday and you start trying to do this, you're not going to finish. Okay, it doesn't matter if you have, you know, 24 hours from Thursday morning till Friday morning, you're going to stay up all night. That's not how our brains work usually, right? New concepts take time to sink in. They take time for your brain to sort of get comfortable with them. So you need to jump into this, start working with it, and then, you know, take a walk, sleep on it, that kind of thing. Come back to it, hit it again the next day, and do this for a few days before it really starts to settle in, right? So this is due about a week and a half from now. So you've got a good chunk of time, but you have to take advantage of that. You really need to start it like as soon as possible, so that you have time to sort of get into this mindset. And once you're in this mindset, right, the course is going to be a lot easier from here on out. And when you move on from Clark, right, and you start, you know, doing Android development or something else, right, having this way of thinking about problems is going to be really, really powerful, okay? So this is a good exercise, and it's pretty fun, and when you get it working, it's, you know, it usually makes people smile. All right, so you're implementing one Java class named Indexer, okay? And the purpose of Indexer is to be able to feed it a file, have it read that file, break it up into words, and then create an index showing where each word occurs in the file, which word number it is, okay? And let me show you some sample output first, and then we'll talk about how we make this work. So here's a test file. It's split over 2 pages, unfortunately. This is a test, so it is, and so I say yes or no, time to test this. What will we do? Test, 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 yes, goodbye. Okay. You're going to split up your input on spaces. Okay, here's a space, here's a space, here's a space. New lines are considered a space, right? So this comma is a test exclamation mark, so it is with 3 exclamation marks and a comma, right? These are the things that you're going to read from your input file. And then you're going to clean them up. You're going to get rid of everything that's not a letter, and you're going to make everything uppercase. So when we break this input file into what we call our cleaned up words, we see this is a test, so it is, so it is. Okay? And then you want to build an index. So that if I ask where is the word so located, you can say so, SO is located, let's see, this is word 1, 2, 3, 4. It's in position 5, 6, 7, and it's in position 8, 9, 10, 11, 12. And it's in position 12. So 5, 8, and 12. Okay? And you're going to build a structure internally so that if you look at a word like so, wherever so is, there's so, it's in positions 5, 8, and 12. Okay, so you're opening an input file, you're pulling it in, you're cleaning up the input, processing it, building this index that basically lists all the words in the file and the positions where they're located. Okay, and a little note here, when we talk about the position where something is stored, start from index position 1. Okay, so this, which is the first word of the file, should be stored at position 1. Okay, and it's also stored in another position here. So in our internal database, the word this is at positions 1 and 21. Okay, that's the whole goal of this, right? Create a class named Indexer that will let you feed it a file, have it build this index, and then ask for some information about this index by using different methods. Okay, so that's the 40,000 foot view. Let's drill down into it in detail. So your class is named Indexer. Okay. And you're only turning in indexer.java. Now you can turn in anything that you want in your repository. I'm lifting that restriction. So you can have test programs, you can have test files, all that kind of stuff. I'm not worried if you turn in more than this, okay? But make sure that when you submit, indexer.java is the thing that I'm going to grade, okay? And it's in the top level directory. So that's the only thing you're responsible for writing, but you absolutely want to write some main programs to test this, okay? The constructor doesn't do anything. Okay, you construct it, you don't pass it any arguments, and it doesn't do anything unless you need to do some initialization, in which case you can, do whatever you like. Alright, so a user, your main program, will interact with Indexer using a series of public methods. The big workhorse method is called Processfile. Processfile takes the name of a file, which could be just a file in your directory or it could be a path name, and it tries to index that file. So it'll try to open the file. If it can't open it or it can't read from it, right, because it doesn't exist or it's protected, this method just returns false and it doesn't do anything else. But if it can open the file, it should do so. It should read in words, it should break them up by spaces, it should clean them up, get rid of everything that's not a letter, make everything uppercase, and then add it to a growing index. Okay, your index is going to be a hash map. So we talked about hash maps yesterday. That's the structure you're going to use. Okay, none of these methods ever print anything. Processfile should not produce any output. Okay, it silently opens this file, reads in the contents, builds an index. If it can't open the file, it simply returns false. If it can open the file, it does that whole thing, builds the index, and then returns true. Okay, but don't print any messages. Alright, once you have built an index by calling Processfile, now your ind object, right, which I set equal to this indexer. So ind is an instance of indexer, so I would say ind.processfile and give it a file name. Well, now this object has inside it this index of words, okay, this hash map. And I can examine that index through a series of methods. So I could say ind.number of instances, and I could give it a word. So I could say number of instances of test. And if this was my input file, right, and I count it up, I'll see that the word test appears 5 times. So in that case, number of instances, parentheses, test, would give me back the number 5. Okay. Most of these don't make any sense if you have not run Processfile, or if you ran Processfile and it wasn't able to open the file. So if Processfile hasn't yet successfully run, return a -1. Okay. If you don't find the word in your index, return a 0. Otherwise, return how many times the word is in the index, which will be, bigger than or equal to 1. Okay, location of lets me know where that word is located in my input file. And so I ask for, what's the first occurrence, the second occurrence, the third occurrence, and so on. Okay, these occurrences start from 0 as usual. The first occurrence is 0, the second is 1, and so on. So if I say location of test, 0, I want to know the first place that the word test appears in my input. And if I look at my input, this is a test. Test is the 4th word. Okay, so location of test, 0 would give me a 4. Location of test, 1 would give me the location of this word test. Location of test, 2 would give me this. Okay, and I'll show you sample output in a few moments. So location of lets me say, where's the nth occurrence of this word. And again, if you have not constructed an index yet, this returns -1. If I ask for the negative first occurrence of a word, return -1, because that doesn't make sense. If the word only appears 5 times and I ask for the 10th occurrence, return -1, because that doesn't make sense. Okay, otherwise return the corresponding location. Number of words just tells you how many times is this word, how many words are in the index. Okay, so if you haven't created an index, return -1, otherwise return the number of words. And then the toString method is just going to return the contents of the entire index, and you just want to return the toString version of your hash map. Okay, so you don't actually have to write anything here, you don't have to do any looping, just use whatever you call your index internally, use the toString method of that and return it. If your process file has been run. If process file has not been run, just return null. So there's edge cases here. Alright, so let's look at sample output. Okay, because those are the public methods. Those are the ones that your main program will interact with. So here's some sample code, and this code's available on the Linux server under /temp, and the test file is also available under /temp. So you can copy these and play with them. But you know, make a lot of test programs. Do a lot more testing on your program than what you see here. So this program makes a new indexer called IND. And before we ever call Processfile, I'm going to call some of the methods using IND and make sure I don't get any exceptions. Okay, so I'm going to print out IND by just concatenating it to a string. I'm going to ask for the number of instances of the word test. I'm going to ask for the first location of the word test, and I'm going to ask how many words are in my index. Okay. All of these are kind of meaningless because index hasn't really been created yet, right? I mean, I've made an index object, but I haven't read a file in yet. So if I do that, what my output should say is index equals null, right? That's the return from the toString. Number of instances should say -1 because the index doesn't exist. Location of should say -1. Number of words should say -1. Okay, next my code tries to process a file called badfile.bad, which guess what, is a bad file. It does not exist. Okay, and so my calls to my public methods should do the same thing as if I had not called processfile at all. So processfile returned false, and then index is null, number of instances, location of, and number of words all return -1. Okay, so that's just testing the edge cases, right? Process the file, see what the status is, and so on. Alright, and then the more interesting test is process a file that does exist. And let's print out the return from process file, that's status. Let's take our index and print it out as a string using the toString method. Let's find how many times bad appears. Let's find how many times test appears. And then let's look at where each of these occurrences of test is. And then let's see how many words we have in our index. Okay, so the return status from process file is true. That's good. When I print out end, I get all of this. Okay. Again, you don't have to write a single loop to make this happen. This is just calling hashmap.toString. But by looking at this, I can tell that the word A appears somewhere in my input file, and it occurs in position 3. And if I look at my file, this is there's at position 3. I can tell number of unique words equals 19. Number of instances of bad is 0. Number of instances of test is equal to 5. Well, if I look right here in my hash map, I can see test occurred 5 times at positions 4, 20, 26, 27, and 28. And then let's make sure that that location of doesn't blow up. So I'm going to print location of test for different location requests, but I'm going to run I from -1 up to the number of instances of test. Okay, and I don't want any exceptions. So instance number -1, well, that doesn't make sense. Okay, so that just returns -1. Instance 0 is at location 4. Instance 1 is at 20, instance 2 is at 26, 3 is at 27. Instance 4, which is the last occurrence of the word test, is at 28. And so if I ask for instance 5 of test, it should give me -1, saying there is no, instance 5, which would be the 6th occurrence of test. Okay, and then number of unique words is 19. So that's sample driver program for this class. But you can make your own, and you should. All right. So how do we do this? So there's also a pair of private methods I want you to implement. Okay. One is called cleanup word, and the goal of cleanup word is to do all of this pre-processing. So, for example, if you have a string that looks like this, cleanup word should take this string and it should return this string. Okay, it does all of the nicety nices to turn your input string into something that we want to actually put in our index. How do you do that? Well, that's going to be a loop, right? Here's one way to do it. Just make a loop that goes through each character of your input string. Okay, how many characters are there? Input string dot length paren. That's a string method that'll tell you how many characters. How do you find character I? String.char at parentheses I. How do you tell if that character that you got is a letter? Character.isLetter parentheses C, right? Will tell you if the value of C is a letter or not. So make a loop which goes through character by character, and for each one, if it's a letter, append it to an output string. So initialize an empty output string, move through here, and for each character, if it's a letter, just concatenate it to the end of your output string. At the end of processing this input, just return the output string. So you've done this in C in multiple instances. You'll do it in Java, but other than concatenation, which is just a plus sign, this looks just like you're writing C code. Okay, so uppercase character.isLetter is a function. You can just put a character in the parentheses here, and this will return true or false to tell you if it's a letter. And char at, right, word.char at parentheses I will give you letter I, where 0 is the first letter. There was some discussion in Discord earlier about using char at. It starts from 0 and it ends at the length of the string -1. There's no null terminators in Java strings. Okay, so if you have a string like hello, length is just 5. There's 5 characters in here. And if you say .character at something, this would be character at 0, 1, 2, 3, and 4. If you do character at 5, you'll get an exception. If you do character at -1, you'll get an exception. So character at, character.isLetter, and char at, character.isLetter, and some simple looping will let you make that method. So take in a word, return a new word. And make that private, okay? That's not something that somebody outside the class is going to use, but you can use this inside your class. And then the other private method I want you to write is add reference. And I want you to write this as its own method, okay? This takes a word and the location of the word in the input file, and it adds it to your index. And how do you do that? Well, if the word's not already in the hash, add it to the hash along with an empty linked list. Okay? And then add the location of the location that's passed into here, add that to the end of the linked list associated with that word. If the index has not been created because you haven't processed a file, just return. Don't print anything, don't throw an exception. Just notice, hey, there's nothing to add the reference to because we haven't processed a file. So just return null. Just return. It's a void. There's no return value. All right. The only field you need in here is something called index. That's the actual hash map that you're going to use to index your words. But you can have other fields if you like. Okay. It's totally up to you. But that one you're definitely going to need, and definitely make that one private so that you can't get to it from outside the class. But you're going to expose a string version of it using the toString method. And you're going to examine it using things like, number of words and so on. All right, so how do we do this? How do we process a file? This is the main method, process file, right? You're going to open the file using a scanner, and we'll talk about that in a few minutes. So scanner we can use to read from system.in, that's standard in. We can also read from a file. If there's an error when you try to do that, just return false from Processfile. But if you succeed in opening the file, make a hash map, okay, call it index, that's your class variable. Key it off of strings and let the data values be linked lists. Okay, linked lists of integers. Make an internal variable, right, a local variable called position counter or location or something, initialize that to 0. And now we're going to loop. We're going to read a word using has next and next from scanner. We're going to clean up the word using cleanup word. And you know, sometimes when you clean up a word, the string you get back may be empty. So if your word looks like this, the output word is just going to be, you know, an empty string because nothing in here was a letter. So check the length of the string that you got back from cleanup, okay? If the length is 0, it's empty. If the word's not empty, increment this counter and then call add reference, right? Pass it the word, pass it the incremented counter, and that stores the new index location into the index. So it's a 3-step loop, right? If there's a next word available, read it in, call cleanup word, and if the word's length is bigger than 0, increment the position counter and call add reference. And that can really be like 3 lines of Java code, okay? And that's it. That's your whole main program. Open a scanner, construct a hash map, initialize a counter, do this 3-step loop, and when scanner has next comes back false, saying that you've hit the end of the file, close the file, and return true from the Processfile method. So the only real hard work that you're doing is inside add reference. And it's really not that hard. So add reference has to do the following. If the word is not in the index, add it to the index, right? So you know, the index is a hash map. Call the get method with the word and see if it returns null. If it returns null, you know the word's not in the index, so put it into the index. And what value do you associate with it? An empty linked list. So this is, you know, index.put parentheses word comma new linked list angle bracket integer paren. One-liner. You can do it in multiple pieces if you want, right? And then add the position counter to the end of the corresponding linked list. Okay, so let's just look at that. We've got a hash map called index, and we want to add position to the end of the linked list associated with word. Okay, it's something like this: index, which is the hash map. Go ahead and get the data associated with word. That is a linked list now. And if we have a linked list, we can say add position, and that'll add that integer to the end of that linked list, right? That one line of code does everything that your add reference needs to do, right? It finds the linked list associated with the word, it adds something to the end of it. And the only extra step before this is try to get the word, and if it comes back null, right, this would blow up. So if it comes back null, make a new entry in your index where the key is word and the data is an empty linked list. Well, how do you make an empty linked list? It's just new linked list, angle bracket integer, paren. So this, which is your Processfile code, and this, which is the add reference code, right, is the main stuff you're going to write. But it's seriously really just calling other stuff. And it almost feels, you know, like a cheat when you start doing this. Because it's like, well, when do I actually write something? Well, you're when you do assembly language, you're taking little molecules of plastic and putting them together to build things. When you do C, you're I don't know what you're doing in C. When you do Java, you're taking like Lego blocks, and you're putting them together. Maybe C is like Lego blocks, and Java is like taking complete Lego kits and just placing them on the ground. So here's my Death Star, and here's my Barbie salon, and now I've made a story. So it's a totally different feeling from C, which is just much more low level. We're really taking things and putting them together. And that's fun. And that's how a lot of programming is done that you'll encounter at a university and, in a career beyond that, like Android development. You hardly ever write Java code, right? You just call a bunch of methods in different classes. And you get to choose, like, what do I want to call? So it's much more powerful and empowering. All right, so clean up word, that's just a for loop, right? Look at string.character at and character.isLetter. And most of these other methods are just wrappers to other calls. So if you want to know what's the number of words, well, look at the hash map. There's a method called size, which tells you how many key data pairs are there in this hash. Well, that's the number of words. So this is just going to return index.size. Okay, this is just going to get the instant num entry on the linked list associated with word. Well, index.getWord gives you a linked list, and the linked list you can say get parentheses instance num, and it gives you the thing stored at that position in the linked list. Right? This is the length of the linked list associated with the word. So really spend some time like digging into the documentation on hash maps and linked lists and strings, and thinking about how these pieces go together. Okay. All right, so grading. Upload to GitLab CSE223PA2 as usual. Make me a reporter. And so points. All right, so I'll download Friday at 8 o'clock from Git, and I'll grade what I get. And I'm only going to look at indexer.java. So if you have other things in there, that's fine. If you have a README, I'll assume you want me to read it, so I'll look at that. All right, so points. So if I can download your project and compile it without errors, you get 20 points. Okay. If additionally you have a class in there named indexer, you get an extra 5 points. So 25 points for just having something that compiles called indexer. Okay. So that should be straightforward. If you have a process file that I can give a file and it will read from the file and store some of the cleaned up words in a hash map, that's worth 10 points. Okay, so something that's doing, ingest and clean and store. If additionally it's creating a linked list and at least storing, one of the locations where a word occurs for some words, that's worth 5 points. If you can save all the words in the hash, that's worth another 5. And if you can save all the words and all the locations of them, that's worth another 5. Okay, so getting the successful process file that builds a nice complete hash map is worth 25, 35, 40, 45, 50 points. Okay, so that's half of your points is getting process file to work, getting a good hash map to come out the other end. All right, the other public methods, toString, number of words, number of instances, and location of, those are 5 points each. Not blowing up and doing the right thing if I try to use these methods and I haven't read a file yet, that's worth 5 points. Okay, that's just edge casey. Implementing the 2 private methods as I specified them, that's worth a total of 10 points. You can make this work without implementing those methods. You can call those methods something else and so on, and your code will still work, okay? But to get these 10 points, I want to see those exact private methods as they're described. So I want a method called cleanup word, takes a string, returns a string. I want an add reference, takes a word and a location, returns void, and they do these things that are specified. So that's 10 points total for the two private methods. And then 15 points for style. So same style considerations as before, but probably more critical here, right? So some people argued their way out of having to put a comment on every single line, like a closing brace at the end of a method you don't need a comment on. And you know, if you say sum equals a plus b, you know, or sum equals first number plus second number, right? But in this assignment, you're going to have one statement like this, and you could write, you know, a paragraph describing what is going on here, right? There's a lot happening here. We're taking the word, we're using that to go into a hash, and we're pulling out a linked list, and then we're adding this integer to the end of that linked list, right? And somebody just looking at this line of code without knowing what index is and what add is and what pause is and what word is not going to know what's going on, right? So you're absolutely going to do a lot of commenting where you're really describing what the purpose of each statement is, okay? Not, you know, pass to the add pause to the add method for the return of get with the word argument, right? But actually explaining what it is that's going on here. What are you doing? What is the purpose of this line of code or that line of code? Okay, so you'll probably have more lines of comments, more comments than you'll have lines of code, right? We'll see how that balances out. So lots of commenting. And the code styles look great from what I've seen so far, so thank you. Keep that up. That's looking really good. All right, submission, CSE 223 PA2 on GitLab. Make sure indexer.java is in the top level of the repository. That's where I'm going to look for the file. And go ahead and push that over, add me as a reporter, and you're good to go. All right, that's about all I got to say on PA2 for now. So if there's questions, we can talk about those. Otherwise, let's talk about scanners a little bit. All right, so we talked about scanners last week in the morning section, and I pointed you to a video on it. But basically, a scanner is a way to do input in a way that lets us break up the input and process it and parse it. So it's sort of the Java version of scanf or scanf. But it's an object. So if we want to read from standard in, we just do a scanner on system.in. And if we want to read an integer, we can say, you know, scanner object.nextInt. And that'll return an integer that's sitting there in standard in that's been typed in. If we want to read something that's just, you know, a bunch of stuff separated by ended by white space, right, or end a file, we can just say next. So let's do some quick code. So scanners, we need to import from Java utility. So I can scan from system.in. And here's a typical loop. So a line is available if has next line comes back true. And let's just print out what this thing is is reading in. Okay, so there's typical scanner code. So has next line tells us, is there a line available? And if there is, next line will return that line as a string. We can save that in string and print it out. Okay. Now, if I try to compile this, oh, it didn't give me an error. It should have given me an error. So when you're done using a scanner, it's good to call a close. Okay, when we get to a file, we'll need that. We don't really need it with system in, but yeah, I won't worry about that for now. Okay, so I can compile this up and scan. So if I run this, this is a test. Hello, cool, bye, typo city, right? And when I hit Control D, it's sending end of file, and scanner detects that, and so has next line comes back false. And if I run this and I feed it, you know, a file as input, it reads from that file one line at a time, and it shows me, you know, each line. Okay, now if I had done has next and next instead of has next line, so I could say, well, has next, and I just set line equal to scan.next, right? Now it's reading one word at a time. So now my input looks like this, right? Import Java class s test curly bracket and so on. It's the stuff separated by spaces, okay, or new lines. And so that's how you want to read your file in, okay? One word at a time. Don't try to read your input file and process file and store it in memory. Okay, that's going to blow up, and it's not necessary. Read one word by doing something like this, and then process that word and go on from there. Okay, so if we want to read a file, we can pass scanner an argument which is new file, and we can put inside the argument to files constructor the path of the file that we want to read. So if I want to read a file called testfile.txt, I can say make a scanner whose constructor is given the argument which is a file whose constructor is given the argument testfile.txt. Okay, this is just the way that we can open a scanner that will read from this file. And to do this, we need to tell it about the file class. So that's importing from Java IO file. So there's a test file. If I try to compile this, though, it's going to complain. And what it's complaining is says unreported exception, file not found exception must be caught or declared. It's possible that when I try to construct a scanner from this file, that it's going to figure out that this file doesn't exist or it can't open it, and it's going to throw an exception. Okay? Since there's a possibility this program might throw an exception, the compiler is not going to compile this program for me. It's going to force me to deal with this. Okay, so we will talk about this in gory detail tomorrow, but we have 4 minutes left. Well, now we have 3 minutes. Let me show you how we deal with this. right, so I'm doing what's called putting a try-catch block around my statement. So this is a statement that can throw an exception. By putting this inside a block that says try, I'm saying if an exception occurs, don't throw up all over my screen. Instead, come down and execute this block of code inside, after the word catch. Okay, so it's setting up an error handler. And this is enough to make the compiler happy that, like, if something goes wrong in making the scanner object, I'll handle it gracefully. I'll come down here, and in this case, I'll print an error message. And one little detail, if I try to compile this, it'll still complain that scan is cannot find symbol scan, right? Because originally I was saying scanner scan equals. Since I said this inside a try block, it's a local variable to that try block. So I'm going to declare scanner outside of this. And we'll do this multiple times in the coming days. So, but that will let us compile. And now, if I run this, it should read from test file, and it prints it out one word at a time. So we'll talk about this more slowly tomorrow, and we'll talk about more details of try-catch blocks. But this is basically all you need to do to open up a file, and once it's open, you can read from the file one word at a time by doing a while loop, while scan.hasNext, and inside the loop, just call scan.next, gives you back a string. And then for Processfile, pass that to your cleanup, pass it to add reference, and you're done with Processfile. All right. So a lot of stuff there to think about. I would say start looking at the documentation for hash map, linked list, dig into those. Maybe take some of the code that's posted on Canvas and start modulating around that, and get an idea what these things look like. And we will talk more about this tomorrow. All right, thanks everybody. Have a great day. I will talk to you later.